Welcome to this video on ecological sampling techniques, designed for Year 10 students. Our learning objectives are to understand why sampling is used, describe how to use quadrats for random sampling and transects for systematic sampling, and analyze data from both methods. Let's start with a recap on ecosystems and biodiversity. Take a moment to answer these 6 questions, which are essential for understanding why we need to measure life within ecosystems. Now let's think about the why of sampling. Consider these questions. Why is counting every organism impractical? Why can sampling lead to biased results? And how can sampling help answer ecological questions? The big picture of sampling is that counting every organism in a large habitat is too big a task. We use representative samples to get a valid, reliable, and unbiased population estimate, such as estimating 10,000 animals in this habitat. One key tool is the quadrat. This 1 square meter frame is used with random coordinates, often generated by a phone app, to prevent bias when taking samples to estimate population size. Here is a worked example for estimating a daisy population. We define the area, take random samples, calculate the mean number of daisies per square meter, and then estimate the total population. Now it's your turn. Estimate the dandelion population in a 20 meters by 30 meters field using the provided sample counts. Calculate the total area, mean number per quadrat, and the estimated total population. Let's spot a problem. An ecologist used random sampling to compare limpet numbers on a rocky shore. Why is this not the best method for their specific question? And how could they improve the strategy for more valid results? For systematic sampling, we introduce the transect. Unlike random sampling, which estimates total population size, systematic sampling uses a transect to show how species distribution changes along a gradient. In this activity, we interpret transect data collected from a belt transect moving away from a large tree. The data shows the mean number of daisies at 2 meters and 6 meters intervals. Your task is to describe and explain the relationship between the distance from the tree and the number of daisy plants using the PEE structure. Use the sentence starter and word bank provided to help you. For your independent task, design an investigation to study the effect of foot traffic on plantain distribution along a footpath. State your hypothesis, choose and justify your sampling technique, and briefly outline your method. Finally, practice an exam-style question. This task involves woodlice population estimation using quadrats. You will explain accuracy reasons, suggest reliability improvements, and calculate the estimated population size. In consolidation, we've covered random sampling with quadrats for abundance and systematic sampling with transects for distribution. Next week, we'll start with a quiz, and later we'll revisit this topic when studying abiotic factors.